In the last part of the lecture, Uma talked about the goal of today's COVID-19 case study, as well as the datasets that we'll be working with. In this part of the lecture, I'm going to reading all the datasets, clean them, as well as analyze them. Before I get started, I just want to quickly introduce the type of notebook that we're working with. This is called a Google Colab notebook, and it's designed to allow multiple people to work on this together at the same time. So if you ever need to collaborate with someone else on the same Jupyter notebook, try out Google Colab. Now let's dive right into it. We're going to reading all the 4 different datasets that has been introduced in the last part of the video. And let's remind ourselves what the goal of today is. We want to measure the impact of the lockdown measures on the spread of the coronavirus. We're going to achieve this by sampling a total of 6 countries, 3 of which have developed economies, and the 3 other countries have developing economies. Within each set of the 3 countries, we're going to have 1 country that implemented full lockdown, 1 country that implemented partial lockdown, as well as 1 country that did not have any lockdown measures, but did announce a state of emergency. We'll first be claiming the cases dataset, and the first thing that should strike your mind is that we have a lot of different non-values, and it's because that many countries or regions do not have the associated provinces or states recorded. In fact, let's take a look at the value counts of all the different countries' regions. We see that China has 33 different rows, Canada has 15 rows, France has 11 rows, and so on. If we index into China, we actually see that all of the provinces in China are recorded here. However, we're not interested in the specific provinces of a country. What we really want is the total sum of the coronaviruses within a given country. That's why we can use a group by operation on the country/region column and take the sum in order to take the total number of cases per country. In this claimed data frame cases, we see that we have a total of 185 countries on the list, and they're all distinct countries. This should actually strike you because it seems like pretty much every single country in the world right now have coronavirus cases, so please stay safe. There's actually 2 more columns that we don't really need here. We're not really interested in the geographic location of the countries. As a result, we can just easily drop the latitude as well as the longitude columns. This just leaves us with the number of cases at each respective day throughout the history of the coronavirus for each country. Next, we're going to look at the development dataset. In this dataset, we see that we have 249 countries in total, as well as their respective development status. Let's take a look at what kind of development status there are. Most countries in the world have developing economies, 50 of them have developed economies, and 20 of them have transition economy. Because so few countries have transition economy, this is not going to be part of our consideration today. We're only going to consider countries that have developing or developed economies. This seems like a pretty clean data set. So the only one thing that we're going to do here is that we're going to set the country column as the index because the values of the index are really meaningless, and we want to be able to easily index into this data frame by just calling the country's name. So we can use the setIndex function provided by pandas, and now we've set the index to be the country. Next, let's examine the population dataset. In this dataset, we have 264 countries as well as their population from 1960 all the way to 2018. We're concerned about the current population, and we don't really want to make use of any of the past population. So that's why that we can simply index out the 2018 column. Actually, before that, let's just once again set the country name as the index. As a reminder, we're going to be using the double index here because we want to get back a data frame, not a series. We're also going to make the name more descriptive by renaming the column 2018 to be the population. now that we have a much clearer data frame and containing the information that we're going to need to work with. Our last dataset measures is a very hefty and a very messy dataset. It contains all the different kinds of measures that all the countries have implemented up to today. It contains a variety of information, and the ones that we'll be particularly concerned with is the type of measure that was implemented, the measure column, as well as the date implemented, when is the exact date that each country implemented a particular measure. I'm going to classify the measures into 3 categories. The first category, level 3, I will classify the countries that have full lockdown. I will first index into the countries with measures full lockdown, and then I will group by each country, and I will only take the first one of each country because we only want 1 row per country. We see that this is also a huge data frame. And because this is very long to scroll through, I just want to get the names of all the countries. So what I'm going to do, I can easily call .index and then .toNumPy, so it displays in the form of a NumPy array. So you can see that these many countries in the world have implemented the full lockdown measure. As I said earlier, we are sampling 2 countries from each severity. And in this case, I have selected Italy and India as the countries that I sampled. Let's move on to level 2. In this category, we are selecting countries that have implemented partial lockdown. Once again, we're indexing into the countries with partial lockdown, grouping by the country name, as well as taking the first row for each respective country. And this should really strike you. We have a really long list with 103 rows. This means that pretty much over half of the country is in either a full lockdown or a partial lockdown right now. Once again, we're going to take the index of the country names, turn it into a NumPy array, and then we see that these are the countries that have implemented either partial or full lockdown measure. Like I said earlier, I'm going to sample the 2 countries myself, China and France. Finally, we have the countries that have only had the state of emergency declared, but have not implemented any lockdown measure. I consider that this is the lowest level, so I call this level 1. I will index it, turn it into a NumPy array, and out of these many countries here, I will sample Canada and Dominican Republic. Now that I've sampled all of the different countries that we're working with, I can just extract these countries, extract these rows out of their original data frames, and then we'll be concatenating together through the concat function by pandas, and then put it in the selected data frame. Just as a sanity check, we have our original 6 countries, we have the measure state of emergency declared, partial lockdown, and the full lockdown. Since we're also interested in the date implemented, we can take a look at this column. Unfortunately, there's a value that's missing here. And it's the row China. When did they implement partial lockdown? I did a little bit of research and found out that they implemented on January the 23rd. So I'll be able to fill in this null value later. For now, we'll be indexing into the measure as well as the date implemented, since they're the only features that we're concerned with. And then I'll fill the null value, which is that date, with the date January the 23rd. Now we want to merge all 4 datasets together, since that we've cleaned them already. In pandas, there isn't really an easy way to merge different data frames together. So I'll have to merge 2 together and then the other 2 together. And so I'll have to do a total of 3 merge operations. What I'm going to do is I'm going to do an inner merge. Because I'm merging on the index, all of the data frames have country as the index. I can just set right index to true and left index to true. And this is going to merge based on the country's name. Our final data frame looks like this. It has measure, date implemented, development status, population, as well as the number of cases at each respective day. However, there is one thing that we're still missing. We don't really want all of the days of the coronavirus cases. What we're concerned with today is we want to find out the impact of the lockdown measures on the number of coronavirus cases. So we want to normalize the data here based on the date implemented. I'm going to import some of the regular expression tools used to extract data. Just a quick detour, regular expression allows you to quickly extract data. And since we haven't covered this in the data lecture this semester, I will just be briefly mentioning it, but I highly encourage you to look into regular expressions, but because they're really helpful in analyzing cleaning data. We're constructing our own function here, it's a list of 14-day window, meaning that what is the 14-day, we want to examine as a 14-day period 2 weeks after the measure was implemented. So the list of the 14-day window, if we pass in March the 17th, 2020, we're going to get back the list of the 14 days period 2 weeks after the measure was implemented. In this operation, we are looking at Canada, and because we know that they implemented it on the March 17th, 2020, we can get a list of windows here, and then we can get the country. We are indexing into the final data frame, and then we'll just get back the row containing Canada, as well as the respective values in the list of the 14-day window. These are the number of cases in the 2-week period following the 2 weeks after the measure is implemented. Now that we have defined our own function, giving us a powerful tool, giving us the 14-day period after the measure is implemented, we can run this on all of the countries. What we're doing here is that for each row, we're mapping the actual date to the number of days in the 14-week period. Oops. Because in here, for each row, we're simply just taking the indexing into the final data frame and getting the list of 14 days according to the date implemented, and then getting the values from those 14 days. And then for each row, we're just concatenating it to our data frame, df date normalized. Finally, we get back this data frame. This is not quite good enough yet though. We do have the number of days here, but they're not really descriptive names. Other people won't really understand what these means. What does 0 mean? What does 1 mean? In order to give the columns more descriptive name, we're just simply going to add the day in front of it to make it more clear.